So when we have a complex fraction, all that means is that there's fractions in the fraction. So that's what the word complex is referring to. So the example you've asked me about is 8x to the negative 1 plus 8y to the negative 1 over 9 times x plus y to the negative 1. Well, recall that from the definition of negative exponent, if you have b to the negative n, it's 1 over b to the n. So in fact, the best way to think about a negative exponent is reciprocal. So I would rewrite this as 8 over x plus 8 over y, since x to the negative 1 equals 1 over x. So 8x to the negative 1 is 8 times 1 over x, which we can write just more compactly as 8 over x. And then over 9 times 1 over x plus y, because it says take this quantity, x plus y, and do the reciprocal of that. So now you can see we have fraction bars in the top, fraction bar in the bottom, and a big fraction. So this is called a complex fraction. So the goal is to not have a complex fraction at the end, just a numerator and a denominator. So there's two very distinct ways of doing that. So let's do it the two different ways. So the first way is the way I find that most students like, which is simplify the numerator, simplify the denominator, then divide. So 3 steps. So the numerator we simplify by putting over a common denominator. So the common denominator is going to be xy. So I'm going to multiply the first fraction by y over y and the second fraction by x over x. So then I'm going to have 8y plus 8x over xy, or yx, whichever way you want to write that. So that's my numerator. Okay, then the denominator really doesn't need any more simplifying except to write as 9 over x plus y. So then we divide. So now this problem is 8y plus 8x over xy divided by 9 over x plus y. Well, recall that that's the same thing as doing 8y plus 8x over xy times x plus y over 9. So we're multiplying by the reciprocal. Well, I'm noticing that there's an 8 and an 8 in this numerator, so I'm going to factor that 8 out and write this as 8 times y plus x times x plus y over 9xy. So what I see is if I have 8x plus y quantity squared over 9xy, and that can't be simplified anymore. So that's your final answer. There's only one fraction bar, so it has been simplified. Okay, so that's the end of the first way. Then the second way I actually prefer. It takes a little more algebra chops, so it's kind of up to you. So let me rewrite the problem again. 8x to the negative 1 plus 8y to the negative 1 over 9 times x plus y to the negative 1. So one of the important things to be aware of is when you have 8x to the negative 1, this exponent of negative 1 doesn't go to the 8. If it was 8x to the negative 1, this would be 1 over 8x. The parentheses give the exponent the power to act on the 8. Otherwise, it doesn't. So again, I'm going to write this as 8 over x plus 8 over y over 9 over x plus y. So now I look for the common denominator of all the fractions I see. So the LCD is going to be x, y times x plus y. So that's kind of a big monster, but it's as simple as it gets. It's as if I had 2 and 3 and 5 in my denominators. The only common denominator is to multiply them all together. So this other way I'm going to show you, you keep the fraction intact. I don't break it up into pieces. And I'm going to multiply by 1. But it's going to be a very fancy one that's going to look like xy times x plus y over xy times x plus y. So this is 1. Multiplying by 1 is legal, right? Of course. So now I'm going to distribute on the top and on the bottom. So I'm going to do this in kind of slow motion. 8 over x plus 8 over y times y times x plus y. And you can put this over a 1 if that helps make it make sense to you. And then I have 9 over x plus y times x, y, x plus y. Okay, so now I'm going to distribute this quantity to 8 over x and distribute it to the 8 over the y. Then on the bottom, you see that the x plus y cancels, and all I have on the bottom is 9xy. Okay, so now in this first fraction, the x's cancel, and I'll have 8y times x plus y. In this second one, the y's cancel, and I'll have 8x times x plus y over 9xy. So then I factor out the x plus y. I have two terms that each have an x plus y in common. So I have 8y plus 8x over 9xy. Now I see I also have a greatest common factor of an 8. So I'm going to pull out the 8 and have 8xy times y plus x. This is a plus over 9xy. And we get the same result. And it's up to you which way you prefer. So either way is fine. The first way was simplify the numerator into one fraction, simplify the denominator into one fraction if it isn't already, and then divide. The second way was look at the LCD of all the fractions you see, multiply by a very fancy 1, which is that LCD over the LCD, which is 1. And then you distribute to each of your terms, and lots of things will cancel, and you get the same answer. So let me know if you still have questions.